Happy birthday, Lomor. Hello ladies and gentle ladies, welcome back to another Minecraft modding tutorial for MultiLoader 26.1, and in this tutorial we're going to be adding some ore generation. So I've already started by registering our blocks, and I've also done all of the data gen shenanigans that are associated with those. Now you see here in my mod blocks I have just made a very quick method that just registers an ore block, and it's just a much simpler way to register them. So all I have to do is say create ore block. Since I want all of mine to be basically the same, they're going to have the same strength and they're all going to require the correct tool for drops, so I might as well just use a method to do all four of them, as that makes the most sense here. Now that this is done, the next best thing to go ahead and do is going to be to create a class that will allow us to store all of the resource keys for our world gen items. So what we're going to do, we're going to create a new package, and I'm going to call this world gen, and inside of here we're going to create a new class, and we're going to call this tutorial mod world gen. Okay, now inside of this class I've just put in the load method and our usual stuff. So then we're going to come to the very top here and we're going to create a public static final. This will be a resource key of type configured feature, and this will be wildcard in both of the two parameters. I'm going to call this example underscore overworld underscore ore, and for now I'm just going to set that equal to null, but we'll come and set that in a second. And I'm just going to duplicate this for the nether and for the end as well. So we'll call this nether one, and then this one can be the end. Once we've done that, we then need to duplicate all of these again, and this time these will be the placed features. So we're going to get rid of this configured feature in here, and we're going to replace that with placed feature. Then on the end of all of these, we're just going to put underscore placed, so we know these are the placed features. The next thing to go ahead and do is to create the actual keys for these rather than having them be set to null. So I'm going to create a private static. This will be a resource key, and this will be of type configured feature, and we'll call this configured feature key, and that is just going to take in a string name, and then we're going to return resource key dot create. We're going to first pass in registries dot configured feature, and then we're going to pass in constants dot id, which will take in the name, and then I'm going to go ahead and duplicate this for the placed feature, but obviously using registries.place feature instead. Then we just need to replace all of these to use these two methods, just like that, and you see you just pass the name in there as well. Okay, with that done, what we want to do is we just want to come into our common class here, and we just want to make sure we are calling this method in here. So we're just going to call tutorial mod world gen dot load. The next thing to go ahead and do is to come inside of our NeoForge, and in here we're now going to do the actual data gen. So inside of the data gen package, we're actually going to create a new package in here, and I'm just going to call this bootstrap. And this is going to be for all of our data gen bootstrapping. So in here, we're going to just create a tutorial mod world gen bootstrapper. This is going to be a final class and have a private constructor. Then inside of here, we're going to want two static methods. So we're going to want a public static void, and this will be bootstrap configured features. And this will take in a bootstrap context of a type configured feature, and we'll put the two question marks in there, and we'll call this the context. And then we're going to want to duplicate this. So we're going to want a public static void. This will be bootstrap placed features, and this will take in a bootstrap context of placed feature, and once again this will be the context. First of all, let's register our configured features. So the way OreGen works, by the way, and how most world gen features work, is that each piece of world gen, say a tree or ore generation or something along the lines of that, is considered a feature, and features by themselves just have a configuration, and it also has the code that defines how this feature should actually generate. So for example, it could be a structure, although I think structures are actually coded not as features anymore, but basically it will define how that feature should generate. For example, an ore ore, it would define how the vein is generated. If it's a tree, it would define how the tree is actually placed, so where all the blocks go and the algorithm used to do that. The placed feature is then used on top of a configured feature. So a placed feature will require a configured feature, and it will define how that feature should actually be placed in the world. So it will define all of the necessary parameters for that, for example, how common it is and those kind of things. It will also define some rules that it uses, for example, such as maybe Y levels that you may want to define. It could also define whether it can spawn in the specific blocks that you're targeting or not. So that is what the placed feature is for. So first of all, let's do the configured features. So we're going to start with our overworld ore. So we're going to do context.register. We're going to pass in our tutorial mod worldgen.example overworld ore, and then we're going to create a new configured feature. We can get rid of what's inside of these angle brackets here, and inside these parentheses we're going to put feature.ore. So what this is used to do is this will define the actual feature that this configured feature uses. Now, by defining this feature, it means we have to supply a specific configuration, and the configuration we're going to use is an OR configuration. Now, I will say you can also use feature.scattered OR if you wish, and I believe this still uses the same configuration. Yes, it still uses an OR configuration, so it would be exactly the same, but a scattered OR would obviously generate the OR in a more scattered pattern rather than the traditional vein pattern. So inside of the OR configuration, we need to provide a list of target block states, and these basically define the specific blocks that we want to allow our block to spawn in and what block would be associated with that block. For example, we're going to use this for stone and deep slate. So I have a stone version of my ore and I have a deep slate version of my ore. So we're going to say that if the target matches stone, it will be our stone variant, and if it matches deep slate, it will be our deep slate variant. So what we're going to do is we're going to do a list.of, and then inside of here we're going to pass in ore configuration, and we're going to call .target, and here is where we define the rule. So we're going to say in this specific circumstance a new block match test, and we can pass in blocks.stone. Now, alternatively, you can do different match tests in there. So, for example, you could do a block state match test, which would require it to match a specific state. You could also say it matches a random block as well. You could also say it matches a tag or a random block state. So there's all these different options. Now, we're actually going to use a tag match test in here. And in here, we're going to pass in stone or replaceables. Next, we need to define the block that will actually be placed here. So in this specific match, what block are we going to allow to be placed? And you see here that this requires a block state. So we're just going to pass in mod blocks, and this one I want my overworld one. So we're going to say example overworld or dot block, and then we say dot get dot default block state. Next, let's define our deep slate configuration. So we're going to do all configuration, and we're going to say dot target. We're going to pass in a new tag match test. We're going to do block tags dot deep slate or replaceables, and then we're going to pass in mod blocks dot example deep slate or dot block dot get dot default block state. Now, after we've done that, we can come outside of this list and we can define the next parameter, which is going to be the size of our ore. So this will be the size of your vein. Now, I'm going to say that my example ore will have a size of maybe 9. Now, obviously, this is up to you. It's up to your balancing and how you'd like your ore to generate. And then the final value that you can pass in, if you wish, is the discard chance on air exposure. So basically what this means is that if the ore can generate next to air, or not. So for example, you can use this to say that your ore may generate rarely in caves because maybe it rarely generates next to air. Or you could say that it never generates in caves, right? It only spawns outside of caves. And then you would do that with a 1.0, for example, would mean that you'd only see it outside of caves. Now, I'm just going to say 0 because I want to be able to find my ore and I don't want to have to like mine for ages to try and find the ore. I just want to find it. So I'm not going to have that, but obviously in a real world mod, you may choose to have that. Okay, now we want to basically replicate this for the nether and also for the end. So I'm actually going to go ahead and copy these in since they're basically exactly the same. Now I have actually chose to use netherrack itself here. Now that is fine. You can do that if you wish, but once again, it's just better to use a tag match test when possible. And I believe there is a nether one. Actually is interestingly not a nether one. You could choose to use the nether carver replaceables if you wish. However, there does not actually seem to be a nether specific ore one. Now maybe something like base stone nether could work. In this case, actually, I am just going to use netherrack itself though, rather than overcomplicate things. Finally, we also have endstone. Now, vanilla doesn't have any ores in the end, so there won't be a tag for this. I believe there still may be block tags dot like base end, maybe? There actually does not seem to be any tags that you could use for the end, which is interesting. I don't know why that's the case. Possible maybe NeoForge has that? Yeah, so NeoForge actually has a tag here in tags.blocks.end where you could use end_stones for your endstone tag down here. However, I am just going to leave it as is just because I think this is fine. Obviously, feel free to do that if you want. You can mess around with this as much as you want. The next thing to go ahead and do is going to be the placed features. So in here, we first of all need a way to actually look up our specific configured feature. And the way we do this is using something called a holder getter. And effectively, this is what the name suggests. So it allows you to get a holder. So we're going to create a holder getter of a configured feature, and I'm going to call this configured features, and I'm going to set that equal to context.lookup, and we're going to pass in registries.configured feature. Now we can go ahead and register our placed features. So let's go ahead and do context.register. We're going to pass in our tutorial mod worldgen.example overworld or placed. And then we're going to pass in the placed feature. So we're going to do a new placed feature. Inside of here, it first of all wants the actual configured feature. So this is where we can use our configured features dot, and then we can say get or throw, and we can pass tutorial mod worldgen.example overworld or, and then we can pass in the actual modifiers that will be used to modify the placement. So we're going to say a list.of. First of all, the most important modifier is the count modifier. So this defines how rare your ore will be, and basically higher the number we use, the more common it will be. So we're just going to do a count placement, and we're just going to say .of, and then we're going to choose a constant int, and I'm going to say of maybe 18. However, you don't need to use a constant int if you don't want to. You can also choose to use a uniform int, and in this case, it will require you to pass a min value and a max value. So will you choose a uniform number between them. There is also a trapezoid int, which you could choose to use, which will basically construct a trapezoid of the count, and this is what vanilla uses for certain things. And if you go into the actual int provider class and you look at the implementations, you'll also see there are some other ones as well. So you can also choose a biased bottom. You also have a clamped normal. You have a trapezoid. You have a uniform. You have weighted list, and you have a clamp. So those are all of the different options you could choose to use. I'm just going to use a constant int just because that's the simplest. The next one you want to do is do an in square placement dot spread, and effectively, from my understanding, is this makes it so that it will be spread evenly across chunks, and so it won't kind of fail on chunk borders or anything like that. That's my understanding of this method. I'm not a WorldGen expert, so I don't know for complete certainty. If I'm wrong, please let me know in the comments and I will pin your comment. But that's what I believe that does. The important thing is that you do need this, and things go really weird if you don't. So make sure you have that one. The next one is also extremely important, of course, and that is going to be your height range placement. And here we can choose the 3 different ways. So we can choose to provide a custom height provider if we wish. However, we should probably use triangle or uniform. So we're going to choose to do a triangle one. And then here we need to pass in a vertical anchor. And this basically will be where in the world should this be as kind of your min value. So as it says here, this is the min inclusive. So what we can say here is you have a couple options. So you can say, for example, the bottom, which will reference the very bottom of the world. No matter the height of the world, this will always reference the bottom of that world. You also have the top, which will reference the top of the world. You can also use something like below top, which will reference how many blocks should it be below the top of the world. Same with above bottom, how many blocks should it be above the bottom of the world. And then you can also provide an absolute value if you wish. Now what I'm going to choose is I'm going to choose to go above bottom, and I'm going to say 10. And then for my max value, I'm going to say vertical anchor dot below top, and I'm going to say maybe 100. Now obviously doing it like this is a little bit risky, because if you had a world which was pretty small, right, so if the height was a pretty low value, then this could obviously not work and you could never get your ore to generate. But obviously generally you're going to be working with vanilla worlds here, but that is just something worth noting. So be careful what you do put with these values. The final thing that we want to pass in here is going to be a biome filter. So we can just say biome filter, and we go .biome, and that just means that we can then later on define that this should be filtered by a biome. Okay, now what we want to do is we want to just replicate this for the nether and for the end. So I'm just going to copy these in once again, and you see these are all of the values I have, but choose yours as you wish. So that is all of my bootstrapping complete. So the next thing we want to go ahead and do is we want to actually use this bootstrapper inside of our data gen. So what we're going to do is we're going to create a new class, and we're going to call this tutorial mod world gen provider. Now this class is going to go ahead and extend a data pack built-in entries provider. And we're just going to make this a final class as well, and we're just going to want to create the constructor that it wants. We'll just choose the first one because we'll fix this in a second. Now in here where we have our constructor, we just want to remove this set of string for the mod IDs, and instead we're going to come into the super here. We're going to get rid of that. We're going to put null, and then we're going to put a set dot of, and we're going to put constants dot mod ID, just like that. What we also want to do here is we want to fix this completable feature. This actually wants to be a holder lookup dot provider. Now what we want to do is we want to create a registry set builder in here. So we're going to do a private static final, and this will be a registry set builder, and we'll just call this builder. That'll be equal to a new registry set builder. Now on here what we can do is we can chain our add calls to add our bootstraps to this registry set builder. So we're going to add in registries dot configured feature, and we'll add in tutorial mod world gen bootstrapper bootstrap configured features, and then we're going to do the exact same thing for registries dot placed feature, adding in tutorial mod world gen bootstrapper bootstrap placed features. Now we also need to add in the biome modifiers, which will actually add these features to some biomes. So we actually need to do biome modifiers separately on both Fabric and NeoForge. Now, since we're already here on NeoForge, we might as well do NeoForge first. So we're going to do a private static void, and we'll call this bootstrap biome modifiers. And this will take in a bootstrap context of a biome modifier, and we'll call this the context. And in here what we want to go ahead and do, first of all, we need to get a holder getter for the biome. So let's do holder getter of biome, and this will be biomes, and that'll be equal to context context.lookup, and we're going to pass in registries.biome. And then we also want to do a holder getter for our placed features so that we can define the placed features for each biome. So we're going to do holder getter for placed feature. We're going to call this placed features, and that'll be equal to context.lookup, and we'll pass in registries.placed feature. Then what we can do is we can just do context.register. Now in here we need to pass in a key for our biome modifier. So we're going to need to create some keys first. So let's do a private static final. This will be a resource key, and this will be of biome modifier, and we'll call this example overworld or modifier. And I'm just going to set this equal to null because we're going to duplicate this for the never and for the end. And then what we want to do is we want to make the method that will create our resource key. So we'll do a private static resource key of biome modifier, which will be biome modifier key. That will take in the string name, and in here we'll do our usual. We'll return a resource key dot create. We need to pass in NeoForge registries dot keys dot biome modifiers, and then we need to pass in constants dot id and pass in the name, and then we can just use this on all of our fields up here, just like that. And now we can reference this key inside of our register method here. And what we want to do is we want to add a feature. So the way biome modifiers work is you can choose to add or you can choose to remove, and you can also choose to add and remove spawns. You can add and remove spawn costs. You can also add and remove carvers as well. So biome modifiers are actually quite powerful, but what we're going to use is obviously for adding and removing features. So we're going to do a new add features biome modifier, and we're going to pass in the specific biomes that we want to choose. So what we're going to do is we're going to do biomes, and we're going to say get or throw, and I just want it to be in the overworld. So we can pass in a tag key here. So we can say biome tags, and then we can say, for example, is overworld. We could also say, for example, is forest. We could say is hills. We could say all of these things. You can also choose specific biomes if you wish. So you can choose, for example, biomes.desert as well would work too. Then we need to pass in the placed feature, and in here we want to do holder set.direct, because this can be a set of features that we want to add to this specific biome modifier. So we can actually provide here a set, but we don't want to use a set, so we actually just want to use a single value. So the direct, you can pass in multiple values, but we are just going to pass in the placed features dot get or throw, and then we're going to pass in our tutorial mod world gen dot example overworld or placed. And then what we want to do is we want to provide the actual generation step, or the decoration as it's called, which will be used to add this feature to, since you have different steps of world generation. Now the one that we want to use is going to be generation step.decoration, and we just want underground ores, since this is for ore generation and none of the others would actually work. And I've just gone ahead and duplicated that for our nether ores and for our end ores as well. So that's just using biome tags.isEnd and biome tags.isNether, and then also making sure we choose our nether and end placed features as well. Now that that is done, we just need to make sure that this will use our builder in the super here, and we also need to add this bootstrap method to our registry set builder. So we just need to add, and we're going to add NeoForge registries.keys.biome modifiers, and we'll pass in tutorial mod world gen provider bootstrap biome modifiers. Then we just need to make sure we actually use this provider inside of our data gen class. So we're just going to do events.create provider. We're going to do our provider : new. The final thing that we need to go ahead and do is we need to actually register those same biome modifiers, but for Fabric, since Fabric has a very similar system, but it's not quite the same. It's not quite shared across loaders. So we do need to come into Fabric, and we need to replicate that. So we're going to come in Fabric here. We're going to create a new new package, and I'm just going to put this in a world gen package, although it probably will end up being the only thing in here, but that's fine, it doesn't really matter. And I'm just going to call this tutorial mod fabric world gen, and inside of here I'm going to make this a final class first of all, and I'm also going to give it a private constructor just like that. And then we're just going to do a public static void load, and in here we're just going to do biome modifications, and we can choose to add a feature. We're going to first of all choose the biome selector, so we're going to say biome selectors, and here you can choose to select how you select your specific biome. So for our overworld orb, we obviously are going to choose found in overworld, but once again the same with NeoForge, you can also choose the specific tag that you want to do. You can exclude specific ones, you can say ones that spawn specific entities as well. So you see here fabric is a lot more powerful and it gives you a lot more access to different things. However, generally you're not actually going to be using any of those, so we're just going to choose found in overworld. Then we once again need to choose that generation step, so for us that is once again just going to be underground ores. And finally we just need to pass in the resource key of our specific placed feature. So we're just going to do tutorial mod world gen dot example overworld or placed, and that is it. Now we just need to duplicate this for both the nether and the end ores as well, and that is pretty much it. We just need to make sure we call this inside of our tutorial mod class on the fabric one. So we're going to do tutorial mod fabric world gen dot load, and that should be it. So we should now be able to go ahead, first of all, make sure you run your data gen. So I'm going to quickly go ahead and do that. Actually, before we load the game, let's also add in some smelting recipes for our ores as well. So let's quickly come into data gen here. Let's come into recipe and let's add in some smelting recipes. So in here, what we can do is we can call the ore smelting method, and we can pass in the list of items that we want to be smeltable. So for example, you would use this for having your actual ore block and also maybe your raw variant if you chose to have that as well. In my case, I don't have a raw variant. I haven't decided to add one. However, that's obviously trivially easy to add, but more importantly, we just want to add in our actual ore block. So I'm just going to use mod blocks dot example overworld ore dot block, and then we need to call dot get as well. And then I'm also going to do the deep slate one as well. So I'm going to do deep slate dot block dot get, and then afterwards this wants the recipe category. So I'm going to say recipe category, and I'm going to choose maybe misc, and then we got the cooking book category as well. Once again, I'm just going to choose, I think, misc here. Then we want the result of this, so that is going to be mod items dot example item dot get. Then we have the experience. I'm going to say something like 0.7 maybe. Then we have the cooking time. I'm going to say 150. And then finally we have the group as well. Now I still don't really understand the group after all my like 9 years of modding. I still don't really know what this group is for, but generally what I put in here is just a string to represent the recipe. What I would just put in here is basically the name of the actual resource. So in this case, the resource is just example. So I would just put the group as example. I think my best guess for what this field is basically the group it will use in the recipe book. So it'll basically group by whatever is in that key. I think that's how that works, but I'm not entirely sure, as I say. Regardless, we're also going to add in an ore blasting method. And once again, I'm just going to pass in my list of blocks here. And then I'm going to do recipe category.misc. I'm going to do cooking book category.misc. I'm going to do mod items.example item.get. I'm going to do the experience as well, so that's going to be the same. Cooking time, obviously we want to be faster since it's blasting, so I'm going to say maybe 75. And then group, once again, I'm just going to do example here. Now I have missed actually the other blocks in here as well, so we can also choose to go ahead and add in our other ones, so the nether and the end. And what I've gone ahead and done here is I've just gone ahead and put that into a list as a variable that we can actually now go ahead and reuse in both of our recipes here. And I'm actually going to change here the cooking notebook category into blocks, because I think that's maybe more accurate here, as they are technically blocks. So now we can go ahead and just rerun our data gen, and we should see that our ores are now generated with the recipes as well. Okay, now once that has generated, you can actually see in your data all of the files have been generated here. So these are all of the JSON files that are actually created from our world gen. You also got the Biome modifiers in here as well, and you basically see how everything we supplied in the code has been converted into this JSON format. So yeah, that is it. Now let's go ahead and run the client. So let's run NeoForge, and also let's run Fabric, and hopefully we should be able to see that this should have our ores in the game. All right, so my game has loaded. Now we're going to go ahead, create a brand new world for both of these. And that is obviously because we want to be able to find our ores much easier. So let's go ahead, create these worlds, and hopefully we should be able to find our ores. So let's have a look. All right, so NeoForge has loaded first, so we might as well go searching in NeoForge first. Hopefully it shouldn't be too hard to find. There it is. So there it is in stone. We should also be able to find it in deep slate if we go a little further down, see if we can find it anywhere. It's not going to be super common, but it should be findable unless I messed up my Y levels, which is entirely possible here. I'm admittedly not seeing it, which is interesting. I probably messed up the Y levels. Okay, so I've done a bit of searching. I have actually just found it in deep slate, so I had to search quite far. I don't know why it's been so... there's actually some more now. I've just seen that. So I don't know why I was struggling to find that so much, but there you go. It does exist in deep slate. It's just rarer for some reason. I don't know if I probably messed up one of the Y levels that's made it a bit rarer. There it is again. Okay, it does exist. Maybe I just couldn't find it where I was for whatever reason, but there you go. So that is NeoForge. Now let's also test in Fabric. All right, so we're going to do a little bit of searching. So let's try and find it in stone first, just to prove that it does spawn in stone in Fabric. I'm not seeing it so far, but obviously it's not the most common ore in the world, so we're not going to find it immediately. I'll be back with you once we have... Never mind. Just as I said that, there it is. And there's also some down here as well. Okay, let's try and find it in deep slate as well. Should be findable in deep slate, but once again, we struggled last time, so I'll be back with you once I find it in deep slate. And there we go. I just found it in deep slate as well. There's only one block here though, which is kind of interesting. But it does exist in deep slate as well, of course. Yeah, I've obviously messed up the numbers a little bit here, but it is actually generating. So that's the important thing. And then you could obviously tweak the numbers to how you want them to be. Yeah, I'm really struggling to find it. So my numbers are definitely off. Okay, so now that we have tested those, let's also go into the Nether. Now, I'm only going to test this on Fabric. I don't see any point in doing this on both NeoForge and Fabric at the same time, just because it's going to take so much longer. All right, so here we are in Nether, and straight away, I'm seeing our ore fluttered throughout the Nether. That's probably because the Nether is significantly more open, so maybe it's easier to find, or maybe my numbers were just messed up for the overworld. I don't know, but that is the Nether checked off. Now, let's also test in the end. All right, so here we are inside of the end. I don't see any immediately, but it should be here. Yep, there you go. There it is. There's some down there. Got some there as well. And presumably, yeah, there's some there. And there's some underneath as well. There's actually quite a fair amount down here. It might not even generate like all the way at the very top. I don't remember what we... there you go. It does still generate at the top as well. So that's good. So there you go. That is it. So I hope you found this tutorial useful. If you did, please be sure to give it a like and subscribe. If you had any problems, feel free to join the Discord, which is linked in the description down below, and I will see you in the next tutorial. Goodbye.